Hello, everybody. Now is noon time, Central Time, April 21st. We still don't see any student login for questions. So I'll go start it and have the overview for lecture 13 and 14 quickly. And then if no one show up, I will actually finish the session. And whoever had the question about the term project, okay, please look at the term project description that we have at the side panel. So basically you go through the course shell, and here we do have the term project description, okay? So regarding what term project need to be done, we do have a video prescription, everything, okay? Roughly, as long as you work on a project that actually is on the programming language, will be acceptable. And what we look for as the programming language, what we are looking for is just one thing. You do have language one translate to language two. Any other project related to this programming language mechanism, if you do that, will be acceptable, okay? And other than that, this is a open project. We do not provide you any other guideline of this you should do or this you should not do. Whatever I list down here as the project idea, 1, 2, 3, it's only a suggestion. You do not have to follow them if you have your own project idea. And the proposal, deliverable, and the final report deliverable, we already actually put it here. For the final project, you need to at least have a written report. And then one presentation, it can be a PowerPoint slides or a YouTube link, okay? And the third one is that I need your technical file to make sure that you do work on the project. You are not copying from somewhere else, okay? So creativity and the authentic is very important. I don't want you to copy from someone else. If you copy from someone else, you may get a 0 point, okay, in the term project. Okay, other than that, term project is an open project. We want you to be more creative. So we don't give you the guideline of what you should do or what you should not do. Okay, so this lecture 13 is on abstract syntax tree. So basically the compiler, you actually pass the pass tree stage. You create a syntax tree. And after that, you need to decorate the syntax tree using attribute grammar. So this whole lecture is on the attribute grammar, and then it will become your semantic graph. Okay, so decorate this abstract syntax tree, and then make it as a semantic grammar. So first thing is that you need to know what is attribute grammar. So attribute grammar is originally you have such a grammar, such as the content-free grammar, and you need to add extra notation to it. So the attribute grammar is like this. Left-hand side is your content-free grammar. Right-hand side is like your E1's value equals the sum of the E2's value plus terminal value, T's value, okay? Terms value. So this is called attribute grammar, okay? And attribute grammar right here, we are talking about value. Okay, value is one of the attributes, and there are many attributes for the same grammar. They may have many attributes. So here when you say LT, okay, LT dot C, okay, LT is a local a term, okay, a term, and this term would be like this, okay. So content-free grammar actually is to decorate your content tree, okay, your syntax tree. So they are reduction and expansion, talking about a tree. When you actually get the value of E times E, you actually summarize to the upper level E. This is called reduction, okay. when you evaluate this E, it expand to a new expression, and that's expression plus expression, and this ID plus ID. This is called expansion. Okay. Now, two types of the grammar. One is called synthesized attribute. Okay, synthesized attribute means that this attribute's value depend on the subfunction of all its sums. Okay, this is called synthesized. So it's actually button up. And then the other type is called inherited attribute. An inherited attribute, the value is actually getting from its sibling and its parent. Inherited attribute is getting from sibling and its parent. Okay. Usually this is like a sum total. Okay, or like error type you propagate through the sibling. Okay. So basically, your tree will become like this one. Okay, this one actually is a top-down parsing tree. Okay. And they are synthesized attribute and the inherited attribute. And very important that when you evaluate them, you need to follow this attribute flow. Okay, this attribute flow. So each rule was expanded based on this attribute rule. Okay. So attribute rule, we also call it action routines. Okay, routine is a function. So basically, you run a certain expansion or extension of the rule. You need to look into the action routines. And then based on this H attribute and L attribute, the compiler will declare the tree. Okay, declare the tree based on these different attributes. Okay. And then there is a topic. Okay, talking about this one is L attribute. Okay. They are error in, error out, errors, semantic table, link, okay, and the type and the name. These are different attributes for different node. Okay. So bottom line is your parser finish the syntax tree. Finish the syntax tree, and then we build a parser that help to declare the attribute. Okay, declare the attribute. So basically, we do have a calculator language, and there's a simple program for the calculator language, and build a syntax tree like this. And then eventually it will be generated with the different inherited and synthesized attribute on the tree. So these are the rules at the end when you finish the tree. And the second half, we do have a guide for writing production rule. This takes longer time, so I don't go over it. You can learn it to write the syntax content-free grammar for the pre. Okay, for the Python, Lex, and Yek. Okay, so let's look at the lecture 14. Lecture 14 is on the Phred and Yek on the calculator language. Okay, so basically your content-free grammar will be provided as the input to generate the Lexer and the Yek. Okay, so there's an overview of the pre. Okay, Python, Lex, and Yek. And then you need to look into the simple program that we have online for the Lexer and you will define a different token type, and then regular expression for qualify for the tokens, and then also the production rules and its related content-free grammar. Okay, and this one can use to generate the different tokens. Okay, and token will be feed into the your parser. Okay, and your parser will be a passing, you will pass. Okay, you pass. So build Alexa, and then you will actually also using the content-free grammar to build your parsers. Okay, so you build your parser. Your parser need to put your content-free grammar and the action routine in this way. Okay, and then it will show content-free grammar has the output file. You can actually see the action routines. Okay, during the passing pass. Okay, so this is a EAC, and EAC has its rule and written in function format. Okay, so with Alexa and EAC, you can generate your parser, your interpreter. Okay, without problem. So that's the purpose of these two chapters. Okay, lecture 13 and 14. Okay, and it goes into many details. So I don't repeat that because we actually describe it in the video. Okay, and let me know if you have more questions. Okay, so if you still have questions, let me know. Okay, bye now.